Can you hear me?
I can.
One thing that I guess that was reinforced to me was kind of how, as in her job, she's not necessarily isolated in her own area. Especially when she talked about how she worked for AT&T, she was mingling with the engineers and industrial designers and seeing what their projects were doing, and her project manager was always involved. So basically her positions at Activision, AT&T, and currently at Facebook, it was more of like a cohesive, symbiotic type of workspace versus being an individual sector and only occasionally interacting from time to time.
Yeah, absolutely. So when human factors is done right, it's done in kind of a team environment, right? Because you don't want to have just a group of psychologists or just a group of engineers or just a group of computer scientists, right? It really should be a cohesive, collaborative effort. There's this propensity in academia to become what we call siloed. So you only interact with those in your subdiscipline, which can lead to great discoveries in your subdiscipline, but very few kind of, massive discoveries that transcend just individual discoveries in psychology, for example, or computer science, right? And so having that ability to interact with the engineers that she's been working with, or the computer scientists, et cetera, throughout the process, I think makes it a much more dynamic and interesting work environment, because you're not just, sitting alone in your office cranking out theory papers. But it also, I think, really gives you the opportunity to make really incredible strides, in the development of these technologies. What other things do we have takeaways for?
One of the things that she really mentioned a lot was trying to sell your ideas and explain why they are important.
Yes, exactly. Yeah, so selling your ideas, really making it clear to whoever the stakeholder is, whether it's your boss, whether it's a customer, why those things are important, right? We know why they're important, but it's moving it out of, again, the theoretical into the concrete. How much time are you going to be saving this company? How much money are you going to be saving this company? What are the things that you can be doing to enhance the overall productivity? And also, again, as we talked about, I think, after Demi's lecture, you're going to be butting up against kind of these external pressures for people who don't necessarily care about what you do. They just want the product to work well, right? And so having a system that is first to market sometimes is a better situation than having a product that works great by the time you get it out to market, right? And so it's balancing those, but you, as a human factors advocate, are always advocating for the consideration of the human, the change in, for example, workplace design, as we're going to be talking about today, et cetera. Anything else we took away from last time?
The biggest thing that I thought was the dichotomy between Demi at Open Table and then Facebook, and seeing just the sheer amount of stakeholders and the people that she would have to please in the different groups, the technical program managers, the project managers. You have a collection of UX researchers, but then also directors, engineers. It was just a lot more going on, to where things like selling the importance of your work becomes even more critical.
Yeah. I mean, Facebook is this massive bureaucracy, right? We tend to think about Silicon Valley as being really agile, really quick adapting, but Facebook itself, I think, has something like 80,000 employees. It's massive. I mean, it really is a really big structure. And so within that comes all these sort of leadership hierarchies, things that you're going to have to incorporate anytime you're trying to make those sales pitch to people. Whereas I don't know how many employees Open Table has, but I can guarantee it's nowhere near 80,000. And so you've got a much more kind of small, unique environment. And that's one of the things. So when my buddy Marlon comes and talks to us in a couple of weeks, he's working at Facebook now, but he's also worked at startups, brand new startups, who, even before they got to market. And so he'll talk a little bit about kind of the structure in these different organizations, different atmospheres, et cetera, things like that. All right, any questions about last time or anything in class so far? Cool. If anything comes up, please let me know. All right. Your fun fact of the day is Samsung tests the durability of their phones with a butt-shaped robot. All right, so they literally have a robot sit on their phones, mimicking a butt. Wasn't it Samsung phones a couple years ago that were having issues catching fire? Yeah. I wonder how that got past the robot butt. All right. So again, if you hear me take an awkward pause, it's me trying to learn how to re-say the word. Anthropometry, there we go, is the study of human movements and body measurements, body dimensions, etc. So we use this data to guide our designs, things like height, clearances, grips, reaching around in workspaces, on equipment, all with the attempts of accommodating the human body dimensions for the potential workspace. From your textbook, I pulled this quote because I really liked it. Inadequate dimensions are one of the most common causes of error, fatigue, and discomfort because designers often ignore or forget this requirement or do not know how to put it into design. Right, so you can think about things you have, some products you have, or workspaces you've interacted with where, at the end of the day, maybe you've got some neck pain because you're looking down the whole time. You've got back pain because the chair isn't adequately calibrated to your lumbar region of your back, etc. And so you'll see all these products marketed as ergonomic design. In reality, you don't have to go through any sort of approval process to put that on there, right? But it's this whole idea of kind of considering the human body. And we'll talk about various aspects of ergonomics throughout the next couple lectures. But again, to reduce error, to reduce fatigue, to reduce discomfort, you want to be taking into consideration the dimensions of the human. Working from home was great over the start of the pandemic, but my desk was such that I was having to look down consistently, such that kind of come July, I was getting massive neck pain from just spending hours and hours looking like that. Luckily, I've got a desk here that allows me to keep my head upright, keep normal good posture, such that I'm reducing kind of neck and upper back pain. And so humans are inherently variable. Right? So considering the human is not necessarily as easy as having a single set of measurements. When we talk about knowing your user in human factors, that includes knowing things about human variability. So things like age variability. Right? Until about 20 to 25, you keep growing. Even if small amounts, keep growing. Towards those later years are when guys tend to fill out a little bit more, look less lanky. However, you got about a 10-year period until you start shrinking again. Right, so understanding how that's going to change over your life period. You also have inherent variability between the sexes. Right? So men tend to be bigger in general, but have more of a V shape, right? Bigger shoulders, smaller waist. Whereas in comparison to women, women have kind of more of what's known as the hourglass shape, bigger hips in proportion to their shoulders, and compared to men, tend to also have bigger thighs as well in proportion. And this is just kind of a fun fact that has very little to do with this, but if you look at the average dimension of a baby's head and the width required for a woman's hips to give birth to that baby's head, we're about at the limit, to the point where any bigger of a skull for these babies, women would have massive problems with hip dysplasia because their hips would be so far outside of what could be supported structurally. Right? And so that's one of the reasons why when babies are born, they have those soft spots, right? Their skulls haven't fully developed. And that's why babies are so relatively useless for the first couple of years of their life, because this gestation that would normally happen in the womb has to take place out of the womb to accommodate for our big old heads. There also tend to be racial and ethnic group variabilities, right? So differences in height, things like arm and torso lengths. So I remember when I was working with the Air Force Academy, I had a pilot friend of mine tell me that there were issues associated with Pacific Islanders being discriminated against for pilot positions because of their BMI, right? So the Air Force, the military tends to use BMI, which is a very imperfect measure of overall size, but because Pacific Islanders tend to have a bigger bone structure than do other racial and ethnic groups, they were being disqualified from certain jobs, even if they were in good shape, because of this BMI. All right, so taking into consideration those things. It's also one of the reasons that Kenyans tend to be very good marathon runners, or at least the top marathon runners tend to be Kenyans, because they tend to have longer legs, which allow for more efficient movement in long distance running. There's also occupational variability, right? And so think about ballet dancers tend to be a lot thinner than average, right? Truck drivers tend to be not only taller, but heavier set on average. Right? And even just think in athletic domains, the body type for a basketball player looks a lot different than the body type for a football player. Right? And so what is the occupation that you are actually designing for? We also have generational variability, right? We tend to get bigger from generation to generation, not just in our gut size, but also in our height. Part of that may be genetics, but a good part of that's probably also nutrition. You know, George Washington was considered a very tall man for his day, but he was about as tall as I am. Which makes me think I was born at the wrong time. I could have been seen as a giant. There's also transient diurnal variability, right? And so what point of the day we measure somebody is going to have slight variations in things like your height, your weight, so things like water retention throughout the day. Also being awake all day and on our feet compresses our spine, so we tend to get shorter as the day goes on. Questions about human variability?
What reason do you think it is that they're tall on average? Like, what's selecting for that?
They tend to be men, and so if we're taking the overall human average, they're just going to be taller than the average, which is including women normally. And then it also tends to be a fairly static job, and so you get higher rates of obesity in truck drivers, I think, than the average. And so I think it is largely kind of a self-selection bias for height, and then kind of just the occupational demands for things like weight. Cool. And so a lot of what we're going to be talking about today for measurements and percentiles is going to rely on a concept I'm sure you all are familiar with, and that is of the normal distribution. All right, so normal distribution is one that is symmetrical around its mean, right there, such that the y-axis is frequency. And the reason we're using the normal distribution, or assuming a lot of these traits are normally distributed, is because it has a known percentile within every point on this normal distribution, right? And so within plus or minus 1 standard deviation from the mean is about 68% of the population. Between 2 standard deviations is about 95% of the population. And then as we start getting out to 3 standard deviations, start getting that 99.7%. All right, so if you had an IQ 3 standard deviations above the mean, or an IQ of 145, you would be smarter than 99.85% of the population, right? Because if 99.7 fall between plus or minus 3 standard deviations, that means you have you don't have 1.5. You have 0.15% in each tail. So if we say you're in the 50th percentile, it means you fall right in the middle. You're higher than half, and you're lower than the other half. So again, when we talk about the percentiles, it's just representing the percentage of the population that falls below that specific value. So again, if you're in the 98th percentile for height, that means you're taller than 98% of people. That 50th percentile would be the mean. And so I suspect most of y'all don't have kids, but if and when you do have kids and you take them to the pediatrician, you'll get charts that say your kid falls in the 50th percentile for height, it means their average height, and let's say the 45th percentile for weight, right? So they're a little bit under the actual weight there. And from those percentiles, you can then start extrapolating and say, okay, how tall is my kid likely going to be? Or how heavy would my kid be in a year or whatnot? So everything we're going to be talking about today in terms of these measurements, now we can extrapolate these measurements to actually absolute values, but we're going to be talking about percentiles for the actual design. Right, and so to get that actual raw value, presented over here, if you've taken a stats class recently and have done any sort of z-score work, you'll know that this is the exact equation we would be using before. You would take the mean, so the average in the population, and you would add to that the z-score corresponding to the percentile you're interested in, times the standard deviation for that. So if I wanted to accommodate for the 95th percentile of hip width, and the mean hip width is 15 inches, and the standard deviation, let's say, is 1 inch, the z-score corresponding with 95th percentile would be 1.65. And so to accommodate for the 95th percentile, a seat would need to be 16.65 inches. I don't think this is accurate. This is just numbers. So, questions about how we go about that? Cool. Easy peasy. All right. So let's do some critical thinking. What percentile would you want to design to for, let's say, chairs, and you're designing for the weight, not hip width or anything like that? What percentile would y'all want to design to? 99.9. Okay, Andrew says 99.9. Why not 100?
Well, I guess 100.
Okay, well, you could do 100, right? But then you also have kind of the absolute extremes, right? That my 1,000-pound life or things like that. And so why 99.9? Why not 95?
Because you want it to cover as many people as possible. You don't want 1 in 20 people sitting on the chair and collapsing on them.
Yeah, so you don't want 1 in 20 people sitting on that chair and having it collapse on them. It also is likely not the case that it would cost all that much more to over-engineer a chair to be able to hold, you know, somebody who is 500 pounds when compared to somebody who's 100 pounds, right? And so in that case, there's not really all that much of an expense to designing for the tallest, or excuse me, for the heaviest rather. What about bookshelf height?
Would you want to do that to like the 50th percentile so that it would fit in like the average house?
Okay, so Hannah says the 50th percentile, so it fit in the average house. Yeah, so you could design it to the 50th percentile in the sense that you're going to have half the population for whom that's going to be too short and a half the population for which it's going to be too tall. Does anybody have other ideas of what you'd want to design it to?
Could you do some research on who usually uses bookshelves and like who reads more often and design it for them?
Yeah, absolutely. So let's say you did some market research and what you found is that women tend to read more than men. I don't know if that's true, but let's say you did. Then it maybe makes sense to design to the 50th percentile for women and just expect that a disproportionate amount of men are going to suffer trying to bend over to get to the bottom shelf. All right, what about for keyboard letter spacing? Oh, Danny says, design multiple heights to accommodate different homes, 1 at the 100th, 1 at the 50th, 1 at, say, the 25th. Yeah, and so bookshelves kind of essentially do that already, or at least a lot of bookshelves do, where it has the variable height shelves that accommodate not only for the different book sizes, but if you want to load up the low part of your bookshelf, you can do that and just put decorations on the top half to make it completely, yeah, modular, exactly. All right, what about keyboard letter spacing? How far apart those keys are on a keyboard? Yeah.
I think
Go ahead, whoever was talking on the iPad.
Oh, I started to say that with that, I would feel like everybody would have the same desire for that, the spacing. So I guess you would just try that for everybody, for the full percentage.
For the full percentage. But there are going to be people like my Uncle Rich who have massive sausage fingers, right? Or people like, you know, Yao Ming, who is 8 feet tall or whatever he is, who may not have very much comfort trying to cram their fingers onto that keyboard, right? Shouldn't we,
Yeah.
Homer Simpson dialing, yes, exactly. So yeah, I mean, that's a good point. We clearly, you know, if we're designing to that 100th percentile, those people with fat fingers are going to need bigger spaced out keys, but somebody with really tiny hands is going to struggle to type efficiently on that keyboard, right? And so,
what kind of keyboard are we talking about? Is it a computer keyboard or a phone like keypad?
let's say computer keyboard. Does that change your
I
answer
think
one way or the
most
other?
people, yeah, because I feel like, I know for example, like my grandma, she hates texting because she thinks the buttons are too close together and small. But like
Yes.
on a computer, I feel like there's very little variability and most people can all work on the same keyboard. So maybe like the 98th percentile for a computer, but probably like the 70th for a phone.
Yeah. And so maybe we're going to the 98th for a computer keyboard, and then just saying, well, sorry, some people are with smaller hands are just going to have to kind of hunt and peck at the keys. Or maybe there's just not that big of a discrepancy amongst, you know, the 98th percentile and the 2nd percentile for typing in there. I mean, we make kids learn when their hands are much smaller. And then you're also right. I mean, depending on the context, right? Is it a computer or is it a phone keypad? Also matters in there. What about car seat height? Car seat height, not car seat height.
I would think car seats would be in the high 90s to accommodate most kids.
Yes, so I'm sorry. Instead of thinking of like kids' car seats, think of like your normal car seats. So the seats that are in your car rather than the car seats. This is confusing.
I
Yeah,
think with
Andrew.
that though,
We'll come back to you in just a second. Go ahead, Andrew.
I think that I would design them for taller people in mind.
Okay.
And then maybe for like the driver's seat, I would let it adjust up and down.
Yeah, so you could have adjustment, right? That's great. We're going to talk about adjustment later on. But yeah, you may want a seat that can accommodate all the tall people, but then have the ability for the munchkins in the group to raise their seat up. Or you'll sometimes see literal like booster seats for some of the shorter people in our lives. 95, 98 to sell as many cars as possible with headrests to an adjustable. Yep. All right. So yeah, so you're starting to get an idea that, I mean, there are trade-offs between a lot of these things, right? So things like a chair, you can design to the 99.9th percentile without really much cost or cost at all to the lower groups, right? But if you're doing for bookshelves, you're gonna have a cost to the higher or to the taller or shorter people, things like keyboard letter spacing, etc. All right, so when we talk about these various measurements, I want us to have some concrete definitions about what we're talking about when we mention these measurements on the human body, right? So height is a point-to-point vertical measurement, right? From the base of my feet to the top of my head. Breadth is a point-to-point measurement from the widest point of my shoulder to the widest point of my other shoulder. Depth is that third axis. So how barrel-chested am I? From a point in the front of my chest to a point in the back. When I talk about distance, that just means point-to-point measurement for any two landmarks on the body. Right? The distance between my knee to my hip. Right? The femoral distance there. Circumference is going to be the closed measurement following a body contour. Right? And don't think about this as an actual circular measurement. Right? If I'm taking the circumference of my trunk here, my chest, so guys, when you go get measured for suits or tuxedos, they will take measurements of your chest, right? They're getting the circumference there. It's not circular, not a perfect circle, but it is that closed measurement. Right? You can get the circumference of your finger, of your leg, etc. And then anytime we're talking about curvature, we mean the point-to-point measurement, but that follows a body contour, right? So we're taking kind of one of those flimsy tape measures, and we're measuring along the contour of your body. All right, so think about that measurement. If you're getting form-fitting pants, somebody with a big old honky-tonk badonkadonk is going to need more fabric in the back than somebody with not much. And so there are a variety of measurement devices. Has anybody in class ever gotten a body fat measurement? Not like a BMI, but like a true body fat? No? It's uniquely humiliating because they will take various ones of these and like pinch your fat rolls and then measure those fat rolls, et cetera, right? With a variety of these different devices. And so you can see the different names up here. So without my glasses on, this is tough. Transtibial length caliper, right? So we're measuring the tibia there. The GPM anthropometer. God, that word always trips me up. For B up here. For C, where are we? Universal anterior, posterior, medial, lateral caliper. Right? And so this is just saying it's a caliper that allows you to get pretty much at every other part of your body. The VAPC caliper, right? And so you can start measuring the actual distances here with this caliper. And then you have a variety of different types of tape measures. And so if you get a chance, post-COVID world, to get a body fat test, go do it because they'll tape you, but then they'll also measure with these variety of calipers of just how much fat you're carrying in various parts of your body. And I foolishly thought if I just sucked everything in, it wouldn't have such high a rating, but then they pinch the fat and the fat comes out. All right. So it's obviously hard to get a truly representative sample from the civilian population, right? You can't get massive numbers of your average civilian to come in and allow us to baseline what the civilian population should look like. You know, one thing we could do with college students, but college students tend to be a little shorter, a little better shape, etc., than do older people. And so what we typically are doing is relying on military populations because they can be, I don't want to say coerced, but you know, part of the whole process is getting all those body measurements for everyone in the military. And so these military populations tend to drive what we're going to be talking about for these standard measurements or these average measurements moving forward. But obviously there are going to be varieties in these populations, right? You're not going to have necessarily the extremes in things like hip width or other aspects of height, weight, things like that, that you would get in the civilian population. But here tends to be the a good approximation for what you would have in the civilian world about for men and for women. And you can see you have the mean, the median, and then your 5th percentile and 95th percentile, right? And so these are all in centimeters. So the 95th percentile for eye height is 80 centimeters, right? So 95% of the population, this is when you're sitting, right? So this is not you standing. Obviously, we're all taller than, 2 3/4 feet. And then your standard deviation, right? And so you can start to see and make comparisons between the heights for men and women. You have your sitting height, knee height, etc., right? And so you can start to get an understanding of how things like desks should be designed based off of, what is the length of distance from the base of your foot to the top of your knee, so you're not banging your knee into those tables. All right, so based off of this, with that standard deviation, if I were to give you those z-scores, you would be able to compute what the actual values are based off of the mean values, right? Does this correspond to? No. So again, this just gives you an idea of the different types of measurements that would be taken, right? So you can look at not only to the height of your knee, to the actual top of your hip, right? So one thing that doctors may do if you're suffering from back pain is take an x-ray and look at your hip height and see if one side is higher than the other, right? Because that can be throwing off your spinal alignment. And so you can see all the different ways in which we can measure you here. All right, one of the things that made Michael Phelps such a good swimmer is he had really long legs, a really short torso, and then pretty long arms, right? So you can see how different aspects of human physiology can dictate performance or comfort in certain situations. And so data for these types of measurements can be both structural and functional, right? So structural is just the data we have on your body in a static position, right? You're not moving. These would be structural measurements. Functional data, on the other hand, are data obtained when the body adopts various working postures. For example, when the body moves with respect to standard reference points in space. And we'll go over some of those examples in just a second. All right, so bear with me 1 second. I'm going to pull up a video here. All right, Zoomies, can you still hear me?
Yes.
All right.
Your thumb, it goes from here to here. This bigger screen goes from here to here. Now, that's either A, an amazing coincidence, or B, a dazzling display of common sense. Pretty sure it's the common sense thing.
All right, so let me transition back real quick, and then we're going to talk about that. All right, Zoomies, you can hear me again? Cool. All right, so clearly at some point, Apple decided to abandon this idea, right? We now have essentially laptops in our pocket. But you can see this initial idea was that, okay, we want people to be able to operate this device with just one hand, right? And so relying on what are the average size movements for the hand such that I can manipulate everything on that screen. Of course, the absurdity of that, and how you can see that this was truly just a marketing gimmick rather than a good idea, is if I have a system, let's draw my phone up here. If I have a system where my phone can, or my thumb stretches to reach here and stretches to reach here, that means as I move it across the screen, probably a good 40% of the screen is unreachable, right, by this own measurement. You have to reposition your hand to actually reach it. And so it's a clever marketing gimmick, but they've clearly gotten away from it, right? And so you can think about these different aspects of what would a phone look like if you could actually reach the whole thing, right? But now you're looking at a phone that is a fraction of the actual size to reach it. Or you can do what Andrew's doing here of moving his phone around in his hand to reach those other parts, right? We've clearly also decided that we're going to abandon one-handed actual control of the phone and at least just go to two hands when we actually need those separate hands, right? And so thinking about what are these measurements that maybe have dictated a lot of what you are doing, or a lot of what the products have decided should be the actual size for your product. Oops, sorry, pulling up the chat here. Oh, okay. In your daily life. And so what are the steps we need if we're going in there to actually redesign a various workspace? First, obviously, determine the user population, all those human variants, right? So age, gender, is it military, civilian, etc. Determine the body dimensions. And then you need to figure out, okay, what's the percentage of the population you need to accommodate with these designs? So in things like cockpit designs for the Air Force, they have a very rigid boundary such that you can't be taller than a certain height and you can't be shorter than a certain height. So they've restricted what those percentiles are. So you know who you're designing for in that case. But in certain cases, you don't know that, and so you have to make that determination as to what percentage of the population you want to accommodate. And as we talk about things like recommended weight limits or potential risks for injury, you have to start weighing the effects of, okay, am I requiring taller people to bend down and pick things up, which can cause injury, or am I causing shorter people to lift up and try and pull things down, which can also cause injury. So after you determine that percentile, think about, okay, do I want to design to the extreme? Do I want to design to the average? Or as Andrew said, do I want it to be adjustable, right? Do I want them to be able to move their seats up and down such that they can see over the dashboard? There are also certain considerations you need to make about the environment in which the person's interacting with the system, right? And so are they going to be in summer or winter clothing? Right? My reach is going to be significantly impeded if I'm in a big old winter jacket. Is it going to be a normal kind of natural posture like I've got now where I'm kind of slouching? Or is it going to be kind of more of an erect, upright posture? And then obviously you want to use mock-ups or simulators to test. I'll give you an example of this. So about a month ago, I built a dining room table for my house, and I had a measurement in mind of 29 inches, how long the legs should be. And so I designed that, and then part of my design plans included me adding kind of an apron to the table. And at some point, I wound up forgetting to cut off those extra inches. And so now I've got a table that's about 6 inches too high. It makes me feel like a child, right? Not a big deal in the development of my own table, right? You want to avoid doing anything like that in an actual workplace design. So get these mock-ups and figure out, are people going to be banging their knees into the tables, or are they not going to be able to reach dinner? So again, you want to think about your users and what are the clearance requirements for those users. Right? So in cases like hallways or doorways, things like that, you want to try and consider what are going to be the largest users of this space and accommodate for them accordingly. I don't know if this is true, but rumor has it that when President Taft was in the White House, they actually had to go in and change the door frame sizes because he was too big to fit to the standard door frames in the White House. So thinking about having a Taft in the White House to make it accessible. And then think about things like the reach requirements for the smallest users, right? If we're designing to the biggest user for clearance requirements, design to the smaller side of users for the reach requirements. So things that need to be reached frequently should be closest to the trunk, right? And so when I say trunk, I mean the kind of core of your body. And again, heavy clothing is going to reduce that reach capability. So is your warehouse, not heated during the winter? That's going to affect people's ability to actually reach. Also think about what are the special requirements for maintenance, right? So it's not just the user of the system, but you want to design the system in such a way that it makes maintenance easy, right? So again, I'll go back to a personal example. When I'm changing the oil on my car, before my Tacoma, I had a Subaru, and Subaru made it really easy to access the oil filter, right? The oil filter was on top of the engine bay. I didn't have to reach to anything. I could just take it off, really easy. On my Tacoma, I have to reach up and around. It's not a control arm. I think it's just part of the frame of the system, but around other hot components to access the oil filter, right? And so they've designed a system that may work very well, but it's a pain in the rear end to try and reach up and grab what I need to twist off. And of course, it's angled in such a way that as soon as I do, oil starts pouring out of the actual filter on top of me. Right? So thinking about what are the things of the actual design of the system to make it easier for other cars. Again, going back to this adjustability aspect. So one size fits all isn't necessarily the best way of going about it, right? It isn't necessarily the best thing to adjust to the 95th, or to standardize to the 95th percentile, right? If you have the ability to adjust, make systems adjustable, right? So again, going back to your seat in the car, not a car seat, you have the ability to adjust in every car how far away from the steering wheel and from the pedals you are, right? It wouldn't make sense to standardize the distance from the pedals because you're now going to have some tall people who are going to be really cramped or short people who can't reach the pedals, right? And so having that sort of adjustment is advisable. And obviously you want to make sure that those adjustment methods are easy to use. I think it was my Subaru. It had the adjustment lever down below my seat, but it was angled the rack on the seat was angled in such a way that once I pulled it up, the whole thing shot back. And so if I was trying to adjust my seat in the middle of driving, the first couple times I did it, it shot all the way back and I couldn't reach the pedals anymore, right? And so you have to learn to kind of brace yourself and make it easy to use such that you can't screw up in catastrophic ways. So think about things like visibility in the normal line of sight. And so when we talked about the sieve model, right, the prediction of what people were going to be paying attention to or noticing, one of the predictors in that was the effort required, right? People tend to be looking at or below that horizontal plane, right? We tend to look about 10 to 15 degrees below the horizontal plane, which is what makes things like computer screens advisable to be just below the horizontal plane rather than way down below. Right? So if you've ever been working on your laptop on your lap for a long period of time, you've likely gotten a really stiff neck and stiff upper back. Again, because you're requiring the erector muscles along your spine to hold your spine in that posture rather than just relying on that biological structure of your system. You also don't want to put things way up, right? That's why movie theaters suck when you go to the front row. You have to look up like this the whole time. That's a really uncomfortable thing, right? That's why nobody wants to go to the top row, nobody wants to go to the front row. In movie theaters, they always want kind of like 2/3 of the way up because that's maximizing the center of the screen right about at 10 to 15 degrees below the horizon. And so we can actually map where various controls should be or displays should be. Based on where they would fall in the actual display, right? And so you can see right down here is that center of the display. And this is the distance above the seat reference point, right, for the average user, right? So this would adjust based off of users who may be smaller or taller. But you can see you have your primary controls down here, and then your emergency controls surrounding that, right? So the further you get away from that idealized location, the less likely it is somebody's actually going to be paying attention to look up. Right? Probably none of y'all, when you drove here today or drove in the last 24 hours, turned all the way around to check your blind spot on the passenger side, right? You made a quick glance over at the passenger side mirror because it didn't take all that much effort. So think about those types of concepts when it comes to the actual displays and design, rather. And so as we talked about with compatibility, kind of these mental models, these groupings of things together, I think we've already talked about this kind of frequency of use principle. So put things that are frequently used together, or frequently used in general, in a place that's the most convenient location, right? Don't make me reach way around the steering wheel to try and get the lights. Make it really easy that I can just reach out from my hand off the steering wheel to grab that light stick. So the most important things, as deemed by what's going to help you accomplish kind of that primary task or that stated objective, should be things that are crucial, or excuse me, should be things that are in a very convenient location. All right, so putting them in areas that are really easy to reach, really easy to see, etc. And as we're talking about this, I'm noticing the irony in talking about screen placement, and this one is well above the horizon for y'all where you're sitting. See, they should have consulted human factors, folks. And then also think about the sequence of use, right? If you're going to have to use a variety of knobs or buttons or access information, one right after the other, don't make me go looking all over the place to find that subsequent thing. Put them all together, make it easy for me to access that information. So I've already talked about, to this point, right, maintaining some degree of consistency such that you're putting these components in the same location. All right, we had that whole example of what Microsoft wasn't doing well in keeping consistent from PowerPoint to Word, I think were the two things we had. And then we've also talked about that control display compatibility. Remember, in the context of the stovetop, right? If you have, these are burners, right? Having burners that are controlled by knobs that make sense for that compatibility puts you in a much better position than does, let's say, if you had them in the back there. Obviously, you also need to provide adequate space between these controls such that I can't accidentally engage something I didn't mean to. All right, so think of the example of accidentally activating that caps lock button when you're trying to press the A, if you're out of alignment. And then again, things that do similar actions should be grouped together. Right, again, that's going to allow for that kind of consistency of your mental model to say that, okay, if I need to increase the brightness or increase the volume, I should be looking in this area. Right, they're doing similar things. Or if I'm concerned with something about the sound, all the sound controls are in a similar area. All right, just remaining consistent. So one of the things you could do is what's known as a link analysis. And so in this case, the thickness of the line represents a level of interconnectedness such that letters which have a bolder line are more frequently used together. So based off of these two link analyses, which one would you rather use for your control? One or two?
Probably two.
Why two?
Well, because it still has those links right next to each other, but it also minimizes the closeness of unrelated keys.
Yes, exactly, right? And so what we've done here in layout 2 is minimize the distance traveled required for similar connections, right? And so if for A, I'm frequently either moving to D or to C, I'm having to move a long way to get to D, whatever D control is, right? It's positioned a lot further away than is B, right? So that's wasted movement, right? I can move things closer to allow me quicker access to them, right? And so in case here, we're not all that close to B, but we also don't go to B that often, right? So when we think about, again, Fitts' law, the speed with which I can register a response is inherently dictated by the distance between those two response options, right? So minimize the distance between related or interconnected linked controls. Questions about that? Cool. And so one of the nice things about this sort of link analysis is it doesn't just have to be for controls, right? You could do this for workspace design, right? If I'm having to go over to the desk over here to get something, and now I've got to walk all the way back over to the other side of the classroom to put that widget down, and now I have to walk over just near this first desk, I can see what the issue is of me going back and forth, right? I can create this kind of spaghetti diagram. So now I can redesign the system in such a way that minimizes that wasted space like you would have over here in group 1 to put things that I need close together. And this is one of the brilliant things about Amazon. Not only do they bring the shelves to the workers, the layouts of items on the shelf are not necessarily conceptually related, but they're related by consumer decisions, right? And so things that are frequently purchased together are together on the same shelf because it allows for less movement of that shelf, but also less requirement of me waiting for that next shelf to come in to sort those options. And I think this slide is out of order here, but we'll do it nonetheless in this order. And so there's kind of I don't know if it's still the case, but when I was in grad school, there was kind of this revolution of standing desks or even treadmill desks. We had one faculty member at my graduate school who had a treadmill desk, and his office just smelled like feet the entire time because he was walking all the time. But you can think about, okay, what about in like assembly lines or things like that? Should we be prioritizing standing or seated work? Right, a seated posture is going to allow for easier maintenance of kind of long-term work, right? So working for longer periods of time, standing for a long time gets taxing. However, a sit-stand desk, those adjustable ones, allow for greater flexibility. And you do have a lot of health issues with long time sitting, right? So I think most health experts indicate that every hour you should stand up for about 5 minutes to help reduce cases of blood clots. I think there are also concerns with cardiac health in general. But if you're going to be standing, you want to develop a work surface that's about 2 to 4 inches below elbow height when you're actually working, right? So you don't want something way down here. I don't know if people can see that on the screen, way down kind of by your thighs. And you also don't want things way up here, right? Because that's causing a lot more taxing of either you bending over or you kind of elevating yourself with your delts and your traps. And then when you are seated, having the working desk at elbow height allows for greater posturing at their workstation. This doesn't really work necessarily if everybody's all over the place. So, questions about what we covered today? Concerns?
I have one.
Yeah.
So when you were talking about accounting for the variance in different people, how do people do this, I guess, per se, for people that would be in like wheelchairs or things? Do they have to consider it separately?
Yeah, so that's a really good question, right? And so there are a couple things to think about for those in wheelchairs, right? One could be the accessibility, so like the width of doorways, right? And so I don't know everything that the ADA, the American with Disabilities Act, encompasses, but the accessibility, just generalized accessibility, is one of those things, right? And so making sure that you don't have a step in a place where there's no kind of ramp option to get into a building, things like that. For cases wherein you would be trying to accommodate for those in wheelchairs for things like reaching, yeah, I mean, so I would be inclined to indicate that, you know, the ability to reach out would be one thing. The ability to reach at kind of your standing height would be another thing, right? And so when accounting for somebody in a wheelchair, ability to reach out probably won't change at all, but your ability to reach up on high shelves will, right? And so you're having to kind of consider the design requirements for, if it is a workplace for people in wheelchairs, or at least if you're not designing for people in wheelchairs capabilities for things like reaching height, you're at least providing some sort of alternative or workaround solution for that. Does that answer your question?
I think so.
Cool. Other questions, concerns? Awesome. Awesome. All right. Thank y'all for being good attendees on Tuesday. Alex, really appreciated how attentive y'all were and the good questions and participation y'all had. So I appreciate that. Next week, we're doing more of this stuff. Your exam is in 2 weeks, not next week like I initially said. Cool. Yeah. Have a good weekend. Of course, Marquise.